Hello friends, I am Aher from RBNB College, Sirampur. Today I deliver a lecture on rotational dynamics. In that case, we study some application of uniform circular motion. The remaining application of uniform circular motion are when a motorbike moving inside the wheel of the death. And last application of uniform circular motion is we have to study the conical pendulum. Now first we study the wheel of the death. Now when motorcycle moving inside the wheel of the death of radius say small r, its radius is small r, and mass of motorcycle is given by small m. G is the acceleration due to gravity. Then weight of the motorcycle is given by mg. So weight of motorcycle is given by mg. When motorcycle moving inside the wheel of the death, then there is frictional force arises between wall of the wheel of the death and tires of the motorcycle, and that frictional force is given by Fs. N is the normal reaction. Now, when this motorcycle revolving in a horizontal circle inside the wheel of the death, then normal reaction is toward the center of circle. It provides necessary centripetal force, and therefore we write normal reaction N is equal to mv square upon r, where m is mass of the motorcycle, v is its corresponding velocity, and r is the radius of that wheel of the death. Now when this motorcycle revolving inside the wheel of the death in horizontal circle, then there is frictional force which is in a vertically upward direction. This frictional force is along the walls of the wheel of the death in a vertically upward direction. This frictional force is balanced by the mass weight of the car. So we write this frictional force is equal to mg. If you consider, this is equation 1, this one is equation 2. Now we have to find out minimum velocity with which this motorcycle can revolving along the horizontal circle inside the wheel of the death. When this motorcycle revolving inside the wheel of the death in horizontal circle, then we know that this frictional force between tires of motorcycle and wall of the wheel of the death is less than and equal to mu s into n, where mu s is the coefficient of static friction and n is the normal reaction. So we get this relation, this frictional force is less than equal to coefficient of static friction and normal reaction. But do you know that according to equation 1, normal reaction is equal to mv square upon r, which is equal to centripetal force, and that frictional force is given by equation 2, this is equal to mg. Substituting both these values in this equation, we get mg, which is less than equal to mu s into normal reaction is mv square upon r. So we write mv square upon r. Now in that case, this m get cancelled. By rearranging this equation, this velocity is the velocity of the motorcycle which is moving inside the wheel of the death, and its a minimum value is given by v square minimum, that is equal to, by rearranging this equation, we get Rg upon mu s, Rg upon mu s. But we have to find out minimum velocity. So by taking square root of both sides of this equation, we get minimum velocity of motorcycle. V minimum is equal to under root Rg upon mu s. This is equation 3, and this equation 3 gives us the minimum velocity of a motorcycle which revolving in a horizontal circle inside the wheel of the death, which is equal to under root Rg upon mu s, where R is the radius of horizontal circle, G is the acceleration due to gravity, and mu s is the coefficient of static friction. So in this way we get the minimum velocity of motorcycle which is moving along the horizontal circle inside the wheel of the death. Now we have to study the another application. In that case we have to study the conical pendulum. First of all, what is conical pendulum? Everybody is familiar with simple pendulum. In case of simple pendulum, we take a light weightless inextensible string. To the one end of the string we connect the heavy sphere, and another end of this string is connected to the rigid support, and when bob move between to and fro, then it is called as simple pendulum. Or definition of simple pendulum is a heavy sphere suspended from a rigid support by means of a weightless inextensible string is called as simple pendulum. Now in case of conical pendulum, the bob of conical pendulum revolving in along the horizontal circle, and as this bob moves along the horizontal circle, string describe the cone, and that's why such a pendulum is called as conical pendulum. So definition of conical pendulum is very simple. Conical pendulum is a simple pendulum in which a heavy sphere suspended from a rigid support by means of a thin inextensible string, the bob revolving along the horizontal circle in anti-clockwise or clockwise sense with constant linear speed, that pendulum is called as conical pendulum. Very simple definition. So what is conical pendulum? Conical pendulum is a simple pendulum in which a heavy sphere suspended from a rigid support and bob revolving along the horizontal circle with constant linear speed, that pendulum is called as conical pendulum. Now we have to derive an expression for period of a conical pendulum. For that purpose we write given quantities. In that case, if m is the mass of the pendulum or mass of the bob or sphere, g is the acceleration due to gravity, then weight of the bob, that is equal to mg. Now when we consider this bob at position B, then forces acting on the bob are tension in the string along the string and directed toward the point of suspension. So first force acting on the bob is tension along the string directed towards point of suspension A. Point of suspension A. Now this tension is resolved into component. Vertical component is t cos theta and horizontal component is t sin theta. Now this vertical component t cos theta is balanced by the weight of the bob. So we write t cos theta, which is balanced by mg. So this is equation 1. Now we know that as this bob revolving along the horizontal circle of radius small r in anticlockwise sense with constant linear speed, then this t sin theta is directed toward the center and which provides necessary centripetal force. So this t sin theta is equal to centripetal force m r omega square. This is equation 2. In that case, m is the mass of the bob, r is the radius of circle, and omega is its angular velocity. During this horizontal motion, this omega remains constant, and that's why this motion is UCM, and therefore we get t sin theta is equal to m r omega square. Now divide equation 2 by equation 1. By dividing equation 2 by equation 1, we get t sin theta upon t cos theta, that is equal to m r omega square upon mg. Now in that case, this t gets cancelled and this m and m also get cancelled, and remaining is sin theta upon cos theta, that is equal to r omega square upon g. This is equation 3. This equation 3 is in terms of angular velocity. But in this we have to find out the expression for period of a simple pendulum, period of a conical pendulum. That's why we have to find out first value of omega. So we can write this omega square is equal to, by rearranging this equation 3, we get omega square is equal to g into bracket sin theta upon cos theta upon r. So in this way we get omega square. Now see this triangle ABC. Now in this triangle ABC, if this is the radius of the circle, so what is the value of sin theta? Sin theta is equal to this side divided by this one. So r upon small r upon L. From this triangle ABC, we get sin theta is equal to r upon L. By rearranging this one, we get small r equal to L into sin theta. L into sin theta. We have to substitute this value in this equation. So we get omega square is equal to g upon r is L sin theta into sin theta upon cos theta. Now in that case, sin theta also get cancelled and omega square will become g upon L cos theta. G upon L cos theta. Now this is the omega square. For the omega, we have to take square root of both sides. So we get omega is equal to under root g upon L cos theta. This is equation 4. Now this equation 4 gives us angular velocity of this bob, which is revolving along the horizontal circle with constant angular velocity, say omega. We have to find out the period of a conical pendulum, and we know the formula for period of a conical pendulum is T is equal to twice pi upon omega. So that is equal to twice pi upon under root G upon L cos theta. Rearranging this one, we get T is equal to twice pi under root L cos theta upon G. This is equation 5, and equation 5 gives us period of a conical pendulum, that is equal to twice pi under root L cos theta upon G. In that case, L is the length of a conical pendulum, theta is the angle, and G is the acceleration due to gravity. Now with the help of this formula, we can find out the frequency of conical pendulum, and frequency of conical pendulum is equal to N is equal to 1 upon T. By taking reciprocal of equation 5, we get frequency. So we get 1 upon twice pi under root G upon L cos theta. This equation 6 gives us frequency of a conical pendulum. So in this way, we find out the period and frequency of a conical pendulum. So in this way, up to this one, we study the application of uniform circular motion. Today we stop here. Thank you.